Hey, John here. Let's talk about C-style strings, all right? And by that I mean anything that's a string literal, like this, or anytime you have an array of characters that you manage as the value of a C string, okay? Now, we got chicken and egg here. What's a string, right? Well, a string, in my mind, is probably named after the idea that if you have a bunch of beads with a thread going through them, a string of beads, as it were, the beads all line up and stay together in order, right? Well, a string of characters, again, this is just my assumption, is so named because when you line them up like this, they all stay in this order, and the notion of keeping them in this group, in this ordered grouping, is maintained. So you have a string of characters, quite literally. That's what I believe that word literally means. It's certainly what it is, regardless of why they named it that, okay? But to me, that all kind of goes together. Now, in a C-style string, we can look in here. There's no tricks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Clearly, there is a 9-character value expressed in these double quotes, okay? If you put characters in single quotes, you're representing a single character. In other words, it would be illegal for me to do this, right? I mean, we all know this, I hope. Right? That would be a character constant, a character literal, I should say, whose value is illegal because you can't have more than one character in a character literal. So double quotes means it's a string literal. In case you never noticed that before. Now, putting this in a double quote like this means that you have 1, 2, 3, 4, 5, 6, 7, 8, 9. In this case, we have 9 characters that we are, overtly see here, plus one more at the end of this series that is a null character. In other words, it's one of these things. All right? Literally, what that means is a character constant, null character. Oops. Hit the wrong key there. Sorry about that. Character, okay? Which is the same as the integer value 0. I'll say same as, wow, I can't type. Sorry about that. Same as integer value 0, okay? But if you just put 0 in your code as a literal, you just defined a literal whose type is int, okay? That is a 4-byte integer numeric value. If you do it this way, and you have a \0 in there in single quotes, this is a 1-byte literal character whose value is 0. In this notation with the / in front of a numeric value, what you're really doing is you're expressing an octal number in there. A lot of people may not realize that's what's really going on in there. You can put a 3-digit octal number in there if you want. Let's not do that, all right? 0 in base 8 is the same as 0 in base 16 and 0 in base decimal and so on. So it just so happens that \0 means 0 in all number bases, and it's the same as an integer value 0 in terms of its value. Its type is a little different, though, okay? So what do we got here? We got a single byte character with a 1. The code for a 1 in hex is 3-1. In hex, the 2 is a 3-2, and so on, up to the 9, followed by this implied null character after the 9, which gives us a total of 10 characters in here. Okay? So the most I can put in a string in a 10-byte array is 9 visible characters followed by a null, if I use that array to hold a character string. Now, I'm going to have a subroutine here. I'm going to call print string array. I pass it a pointer to a character constant. We'll talk about that in a minute. And we give it a length. So what this thing is going to do is I pass it the address of this array, and I give it how many bytes are in that array. In this case, it's because a character is a single byte, size of AY is the same thing as saying how many elements are in there, okay? is maybe a little bit cheating and messy, because if this character is represented by a 2-byte character, which I don't know of any systems that implement character that way. They have these things called wide characters that are sometimes 2 bytes or more, but that's not a char, okay? Or some people call that a char. Anyway, this is the number of characters in the array, and I admit this is a little bit sloppy. And then the address at the beginning of that array. So what is this thing going to do? It sets up a loop. I is 0, I less than length, and plus plus I. It's going to go through one at a time and print out these characters in different ways, is what this thing is going to do, okay? We already talked about this static cast and stuff like that. This is actually some old code in here that's getting a little bit stale. They clowned around with this before talking about it. Let's get this stuff out of here. Okay. Those of you that know what show base is, it's annoying when you're printing the value 0 out. I'm going to hard code this leader. If you don't know what show base is, don't worry about it. That's just for people that are going to hound on me about it. If you know how to use show base and get the 0x to print out before the 0 and have set 0 work and set fill work all at the same time, let me know in the comments below. I really would appreciate it. Otherwise, it's just not something I'm interested in at all, because it doesn't do what I want it to do, which is print out 0x followed by a 2-digit decimal number with leading zeros, or 2-digit hex number, I should say, with leading zeros whose value is given by the character code that we print out up here. So what is this? On one big line, I say P, open square bracket, I, close square bracket, equals, and then we're going to see the character code, because P sub I is of type character, right? P is a pointer to character. We add a subscript. This is the value in the string at index I, and I will go from 0 to len minus 1. In this case, 0 to 9, right? Then after that, I'm going to print 0x, and I'm going to print out a 2-digit hexadecimal value that represents the numeric code of that character. And then after that, I'm going to print the decimal code number of that character. All right, so that's what all this malarkey means inside here, right? So I'm going to print all that out, and then I'm going to do what? I'm going to print out size of the array, and I'm going to call this getLength function. And getLength gets a copy. It's going to get a pointer to the array as well, all right? Well, let's look and see what the getLength does up here. GetLength, what we're doing in here is we're saying here's a pointer to a string. I'm going to use it as a string. It's a pointer to a character. I remember the value that I was passed. And I say, well, star P. Remember, 0 is false, and anything that's not false is true. So while the value of the character code is not a 0, in other words, when it's not this null terminator that comes after the 9, okay, I'm going to point to the next one. And I'm going to just keep doing that until star P equals 0. At that point, P will point at the null character after the 9 in the string that was passed in. If I take the address of the null that follows the 9 minus the address of this 1, which I saved in P0 up here, I'm using pointer arithmetic to calculate the number of characters, the length of the string, number of characters in this string that I've been given. All right? So I have this thing that prints it out in its entirety. It's going to print out all 10 characters. Then I'm going to ask how many characters are in the string pointed to by P. And I'm going to point out that, print out, rather, I should say, that length, okay? Now let's take a look at this const stuff. As I mentioned in the comment up here, if I take a char star P, which we already know about, and I'm making a const char star P, what I'm declaring is a pointer to a character constant. What I'm doing is I'm making the guarantee to any function that calls getLength and gives it a pointer. It's given a guarantee that this function's not going to modify the memory that's pointed to by this P over here. So you can call getLength and know that getLength is not going to mess up your data. If you don't understand what this function does or how it works, you're at least guaranteed it's not going to ruin your string. Okay? And as the writer of getLength, what this does for me is it says if I make a mistake in my code here and accidentally modify something that P is pointing to, maybe this is a more complicated function, like this stuff down here. If I accidentally put a P sub I equals 3 in here, which would be a really gross mistake, but, you know, with all the typing going on down there, all this stuff going on, you could make a mistake like that, right? But and what it would do is the compiler would say you're trying to modify a constant, and you get a compiler error. So this is very handy, okay, for two reasons. One, it assures the caller that you're not going to wreck the thing if it calls this function. And two, when you're writing this function, it assures that you at least did what you intended to do, and it cuts your debugging time down when that complexity goes way up. All right, so let's compile and run this thing and see what we get. All right, so remember we set this to 1, 2, 3, 4, 5, 6, 7, 8, 9, followed by a null, because that's what you get from a character string. And this is what you have here. These are the characters. Remember when I said P sub 0 equals, and then I said P sub 0 in the source code. Let's review here. P sub whatever in the square brackets equals, and then I just put the character in there. I probably should have put quotes around it or something. That'll make something else here more obvious, because when we print out things that don't have a printable facade, right? There's no printable glyph for them. We want to see it like down here. We'll talk about that in a second. So remember, I said equal P, or rather the array AY equals a double quote 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I ended it. Well, after the 9 is this null down here, this 0. The 0 value in hex is 0 in decimal, and it's 0 in octal. All right. The 1 in hex is a 49. In decimal, it's 31. Or rather, in hex, I should say, it's a 3-1. In decimal, it's 49, okay? I find it easier to, honestly, I find it easier to work in hex when I'm looking at these values, because they purposely chose them so that all the 3s are the numeric digits, and the 41 is a capital A, for example. I can never remember the decimal values. They just come and go at weird intervals when you're working at the low level in the computer. The hex values are pretty handy, in my opinion. All right, so if you go to print out a character that is not printable, it could do all kinds of crazy things on your screen. Luckily for us, if you print out a character whose value is a 0, it doesn't print anything at all. It's a null, okay? And that's one of the reasons I put the single quotes in there, so we can see that nothing came out. You can also tell because the indentation's wrong. There's a missing character here. Now we say size of array equals 10, and we called that getLength function that we wrote. Passed it the pointer to the first character in that array, and it came back with a 9, okay? Because the length of a string is, by convention, the number of characters that don't include this trailing null terminator. Let's look back at the code again. We have 9 characters in our string that we initialize. GetLength returns 9, so let's cut this thing down. And see what happens if I only put 6 in there. We know it'll have a null after the 6. Well, what about the other 4, the other 3 characters in there, right? If there's 6 here, there's 4 more out to the 10. Well, whenever you initialize an array, if you partially initialize it, all of what remains will be set to 0. So we can be rest assured that if we run this right now, when it calls print string and we give it the array, we'll see 1, 2, 3, 4, 5, 6 followed by 0, 0, 0, 0. because there's 4 nulls after this. There's the 1 that's there because it's a string, and 3 more because we initialized an array without completing all of the values. All right? So there's the null terminator, and these are by definition nulled out because we didn't completely initialize the array. We call getLength, and obviously it will return 6 because that's a loop that goes through. As you recall, it starts at the first element in the array and says, is that non-zero? No, yes, 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 yes. Finally, it gets down here, and it sees a null in there, and it is now equal to 0, so the while loop ends, and it takes 6 minus 0, right? The address of the 6th element minus the address of the 0th element using pointer arithmetic. And because every single element in this data type are single bytes, it doesn't matter whether we're thinking in terms of bytes or elements at this point. We're going to get that 6, okay? So that's how this thing works. The big takeaway is, what is a string? How is it represented? Now, let's play around with this a little bit. Let's do this. What happens if I say a sub 2 equals this null character? Oh, jeez, my keyboard's going nuts. Crazy video. He's losing it. Here we go. All right, so now, after I've done this, what is this thing going to do down here? Did I change the size of the array? No. The size of the array is 10 characters. No matter what you do to its value, the size of this array is 10 characters, which is 10 bytes. This will always say 10, okay? What about this thing? Well, if I put a null here, which is what I'm doing, if I set a y sub 2, if I just can't type right now. I don't know what's going on here. Maybe I need more coffee. I don't know. If we set ay sub 2 to null, what we're doing, there's ay sub 0, ay sub 1, ay sub 2. Right there is this 3. If I change that to a 0, how many characters should getLength return? It's going to return 2, even though there's 5 in there, because of the definition of the length of a string. It's how many characters you get until you run into that first null in there, okay? Look at the code here. This is what this does, period. That's what that function does. So let's go ahead and run that thing. Surprise, surprise. That came back with 2. All right, we could call this and print it out again. Why not? That's what I thought I did in the first place. And my spastic keyboard operation here going on. I'm losing my... make, run, there we go. First time through, there's the 6, followed by the nulls. Here's the second time through. We poked a null in there, and ay sub 2. That's what makes perfect sense that there'd be a 0 there right now. And it makes perfect sense that this other garbage is still sitting down here. The length is 2 because there's 2 things before we hit that null. The size of the array, no matter what, is always 10. Because that's the size of what we defined up here. We could just as easily make it 20. And generate much more output, but, you know, do the same sort of thing. Here's the first one. Here's our 6, followed by all padded out with zeros, we say. This is padding. Sometimes the word used for what you do to the extra items. Here's our other one, again, padded out with zeros, and then we poke this extra 0 in there. You can clearly see the size has now gone up to 20. And remember, this is in bytes. The only reason this is the same as the number of elements is because the element size is 1 byte. Do not get confused. Do not get a bad grade on a quiz because you're confusing the bytes with the elements, all right? Don't get confused. Length. How many characters are in this array, not including the first null? All right, now you don't have to count your own strings and and calculate their length and so on. There's a standard library function for that called strlen. All right, now I wanted you to see how it worked before we just blindly used it. If you go in there and grab the source code of the Unix standard C library. You'll get this. You'll get the source code. It's probably written something along the lines of this. All right, it could be done in other ways, but that's roughly how the thing works. If we compile and run it again, we'll get the exact same output. No shock there. 20 and 2. We replaced our get length function with the strlen, because that's what strlen is. You don't know, man, strlen. You can read the online manual. For all the standard C functions, they're all online, what we call man pages. And you can clearly see it too says const char star s. It returns a size t. What did mine return? Did I do that right? It doesn't, for me, yeah, I even made it a size t. It's an integer of some kind, okay? All right, so I deleted our get length. We're going to use the standard one, all right? Now, this is a C standard library function. It's not a C++ function. This string here is what a lot of people call a C string. That's totally different than a C++ standard string, all right? Don't get confused. We'll do another lecture on the C++ strings later on. Right now, we're only talking about a character array whose values are used to hold the characters of a C-style string, okay? And because I've changed that to 20, my documentation over here is wrong. Don't let that get you confused. All right. So what can we do with these C strings? All right. Now, there's a whole bunch of these functions. They're all in string.h or C string, okay, which is totally different than the C++ string. I cannot stress that enough. These are C strings right now, okay? So what do we got? We already saw strlen. We can know what that thing means when we run this thing. That's how many characters are there whose values are not null in the string before you hit the null. Before you hit the first one. It's not the total number, right? Because when I wipe out number 2 here, it returned a 2. It did not return a 2 plus these 3 and give me 5, okay? So yeah, I got to be careful how I say that. I may be a little overgeneralizing. It's how many characters are not null followed by the first null. Okay, the rest of the string is ignored once it reaches that first null, in this case at a y of 2. Now, what happens if we want to take a string and we want to append something to the end of it? Well, first of all, we need to be careful because right now we only have 20 characters. Granted, we're only using, at this point, 3 of them. Remember the null, you got to account for that null. I can't put 20 printable characters in there and then add a null after that because I'll be writing into something that's not part of this array. All right, that array is 20 bytes, period. Not 20 bytes plus a null. All right, this one here is 6 plus the null. But you'll notice this is not an array. This is a string literal. Okay, so do not screw this up. This is great fodder for quizzes and things like that. So just be careful. This stands for string catenate. So if I want to, I can say catenate to the end of AY, ABC. And it's on me to make sure that AY has to be big enough. All right. So let's go ahead and do this and see what happens now. I don't need to print. Well, let's go ahead and print out the whole length for a little while longer. We can keep this in mind and know what we're doing. All right, so now what happened? Here's the first one, 6 followed by the padding. Here's the one that we modified with the 0 by poking in a null after the first 2 characters. And now look what we got. We got 1, 2 followed by ABC followed by the nulls. We catenated a 3-character string with a null onto the end of the string given by the variable AY, which starts right here before we modify it. So it goes in here and it finds the null. And says, okay, the current value, the currently usable string stored in this array has these 2 printable characters in it. When I say catenate, it replaces this first null it finds with the first character. As you saw, I catenated an ABC. So it blew away this null and put an A in there, it put a B here, it put a C there. And because now it's supposed to end, it overwrites the 6 with the null. So this right here is the 1, 2, ABC followed by a null. That string right there. So again, the takeaway here is that you need to make sure there's enough room to hold the thing you're catenating onto there. Okay? And don't confuse the size of an array with the number of elements in an array with the length of a string stored in a character array. All right? Those are 3 different things. Only by coincidence does a character have 1 byte, and therefore size of happens to return the number of elements in this one single case. Oops. So I can still do more catenations here, DEF. All right, let's go ahead and do that. And run that one, and we'll see it keeps getting longer, right? So here's the 1, 2, ABC, and then I did another catenation of DEF onto the end of that one, and we're good here, right? Now look what happens. Just to drive the point home, let's go ahead and do this again. And now let's put in a strcat of XYZ. Now, what do you think is going to happen now? Well, what's going to happen now is by poking this 0 in there, it goes back to just having the 1, 2, and the null. Then I'm going to strcat XYZ onto the end of that string. So I'm going to see the 1, 2, XYZ, then it's going to have the null, and then we're going to see garbage left over from these values before, because it just doesn't matter what's in that character array after the null, all right? Again, just to make real sure we know what a string is, okay? Here's my, 1, 2, ABC, DEF, and it's null, okay? I poked a null over the A here, as you saw. I could print that out. I'll leave that as a task for the viewer to write up your own little test case. I then catenated the XYZ, and of course it goes here. Where else would it go? It goes over the null that I poked in after the 2, and it puts in the XYZ, and it puts a null to terminate that catenation, and it leaves anything down here that was there before is left untouched. Okay? Again, excellent quiz fodder. No, it doesn't go and zero this stuff out. How could it? How does it possibly know when I call strcat and I give it this? It's a pointer to a character. And I give it this string over here, which is 3 characters and a null after it. How does strcat know how big this array is? I'll give you a clue. It doesn't. Therefore, it could not, if it wanted to, it could not know how much data is down here to clear out. It can't know. Therefore, it won't do it. It doesn't make sense from the get-go, is my point. All right? Again, just to confirm what that's all about. You have a whole bunch of these little functions. Strcat. Let's look at the man page for strcat. We can get a formal definition of what this thing does. It says it appends the source string to the dest string, overriding the terminating null byte, which we just saw, at the end of the dest string, and then it adds a terminating null byte, which, again, we saw, because it always needs to have a null at the end of a C-style string, otherwise it's not terminated, and if you then use it, there's no way of knowing where that string ends. Again, this is just for C-style strings, all right? Now, it does go into some weird cases where if you copy the string over itself, bad things can happen and stuff like that. In other words, don't overlap your source and your target strings. You can end up with a destructive copy. And then it gives you related functions, in this case, strncat. So what's going on here is it says it'll use at most n bytes from source. So if you decide, hey, I don't want it to go willy-nilly and write too much in here, I can at least limit how many I get from here. You know, if this is a user entered data item or something like that, you can say, you know, do not copy more than 5 or something like that. And they give you a nice little description. In this particular case, on this man page, it's really nice of them. They come along and they give you this algorithm in here and says it might actually be implemented like this. Gives you a sample source code of how this particular library function would be implemented if you care to know all of the details. Continuing down the page, it talks about, you know, where it came from and all this other stuff. Wow, all kinds of details about what it really means. And then down here it says you might also want to look at these. There's a bunch of other things: memory copy, B copy, string copy, and so on. All right. So copy and cat are two different ways to move around, copy strings around, and make big ones out of little ones. This one here is also interesting. Man string tells you about a lot of functions that are in one big header file. All right. So, and that's what I wanted you to see. We see all these different types of library methods that are all defined in here that you can use. Case insensitive string comparisons, find a character, strcar, strr, compare two things, copy, all the duplicate things. A lot of utility functions that you might need when you're working with C-style strings, okay? Let's look at some of these. So we just did cat and stuff like that. Let's delete all of this code up here. That'll just create some noise. We already understand what all those functions do. So we have a 20-character array that looks like this. Let's create another one. Char. Let's call this A2 and make it 20 bytes long. Let's not initialize it to anything, okay? Just for fun, let's print it out. What happens if you do this? Well, literally what's going to happen is the compiler will warn you that you're using something that may not be initialized. So let's see what that does. Wow, I have wall on and it did not warn me. Why did it not warn me that? It's because it doesn't know that I am using. It's because I passed it to a function and it gets used inside there. That's too much for the compiler to foresee what's going on in there. It can't do this. If I directly printed it out in main, it would gripe that I'm using an uninitialized array. But passing it somewhere else, it doesn't know enough to make that check, I guess. That I was kind of surprised that it didn't get that, because it's declared as a const, and therefore it suggests that someone's going to use it for something that might be garbage. And you can see what happens down here. When I print it out, it had crap in it, okay? So here's the 20-byte array that has the 1, 2, 3, 4, 5, 6. All right, 0 to 19. Here's the one that's uninitialized, and it's got junk in there. Characters that don't even print right, okay? Weird things, and sometimes you'll see smiley faces and other such things, and, values that don't make any sense at all. Interestingly, the size of AY is still 20, and the strlength is 6. Why is that? Maybe it's because when I printed it out, I printed out the wrong, yes, this is dealing with AY. Let's take this and print out strlen of A2. Now the thing is, if you're going to go ahead and use things like strlen on an uninitialized array, it could literally go on forever, in theory, because if it doesn't reach a null character by coincidence, now it will in this case, it'll count these because they're not zeros. It'll count all these as part of the string in this particular example, and then it'll see a 0 here and go, oh, your string must have 6 usable characters in it. All right. Now, that was the old program. Let's compile it again. Who knows? Every time you run it, it could be different. What comes out? It says it's 6. Okay. And notice it is different this time. Let's see if it does it again. Look at that. Every time we do it, it's some different garbage in there. This is what you get if you don't initialize your variables. So it just so happens it coincidentally comes out to 6 quite often here. Picked a random one where it might not. Okay, but no. So anyway, so it's got this junk data in here. it gets down here and it gets a 0. And that is what the length of that string is, because it's non-zero characters followed by this null. And index number 6, therefore, its string length is 6, in spite of the fact the size of that character array is 20, because it's 20, because I said it's 20. All right, now, why am I doing all this? Let's look at what happens if I use string copy. Okay, and the way this thing works is it's destination, comma, source, and the way this works is string copy will copy all the bytes from AY until it reaches a null, and it includes that first null it runs into the destination, which is A2. After this is done, let's go ahead and print all our fun stuff out again. So now what happens? I'm working backwards. You can see it worked and left garbage down here, okay? So let's see what's happening here. How is this all working? Let's clear the screen because there's too much going on. All right, now I hit a bunch of enter. I do this on purpose, so when I scroll back, I don't have to look through and read every stinking thing to figure out where I ran my program. If there's, 5 program runs in a row, take me 20 minutes to find out where I started the new program. By doing this, it's obvious, okay? So here's me running the program, 1, 2, 3, 4, 5, 6. I print out, that's the AY. Then I print out my A2 here, which was uninitialized and has garbage in it, okay? Then I string copied AY, which is value that looks like this. 1, 2, 3, 4, 5, 6, and all nulls, into A2. Now look what I got in A2. 1, 2, 3, 4, 5, 6, a null, followed by garbage down here. So string copy replaces only the characters, and that first null leaves everything else alone. Just like the cat, there's nothing to tell it how big anything is. It can't null out the rest of A2. Even if I wanted to, it could not do that, all right? Do not confuse what your intentions are or what your beliefs are with what the thing is to work with, all right? Think in terms of what it is and not what you want it to be when you're working with these things. So let's look at that ncat. So if we copy some stuff in here, now let's type in strncat. Now remember, the way this thing works is it says catenate the contents of AY onto the end of A2, which already has a copy of it, but that's okay. But let's put a length limit of 3 on here, okay? So what it's going to do now is remember, it copied the 1, 2, 3, 4, 5, 6 into A2 right here, because that's what string copy does, as well as that null in there. strncat says iterate across A2 until you get to the end of the string and you found that null. Starting there, copy all the characters from AY until either you've copied 3 or you've reached the null in AY. At that point, stop copying. Okay? Now, notice what the problem with this is. You got to ask yourself, if you stop early because you reach this 3, does it still null terminate A2 or not? Well, if you don't know, read the doc. strncat, and we were just looking at it, right? So what does it say in here? If source contains n or more, then it'll take the whole thing into the destination plus the null byte. Therefore, the size must be bigger. But if it's less than n, what does it do there, right? This is strcat. strncat says the resulting string in dest is always null terminated. Therefore, there's the answer to our question. And to be honest with you, I forgot, because there's some functions that work differently. I didn't want to lie to you. But, hey, this is how you figure this stuff out. All right, so let's look at what happened in here. Let's go ahead and play our game with this thing and run it again so we can figure out where it starts without having to look for 20 minutes. Okay, there's our 1 to the 5, 6 and all our nulls. Here's our garbage in A6, followed by our string copy into A6. Now remember, after the copy, I called cat. Or more accurately, strcat. And I said, limit yourself to 3 characters. So I would expect to see 1, 2, 3, 4, 5, 6, and then 1, 2, 3, and then a null in here. Notice all this junk in here. It's just coincidental. If we have the 3 characters in here, this number 9 should be a null after that. And these over here will still be the same garbage at 10 and so on, right? So if we come down here, what do we got? Here's my 1, 2, 3, 4, 5, 6. Here's my 1, 2, 3, because I said limit yourself to 3. There's a null in here because the manual page says the dest will always be left null terminated. So when I limited it to 3, it still put a total of 4 bytes on the end of this previous string because of this additional null, and it left P10 through whatever else alone. Here's P10 up here. It's negative 125, 106, 17, negative 125. Once it does this null, it's done, and it leaves everything else sitting here, okay? Again, great quiz fodder to make sure the student understands what's going on. Strcpy is the thing that does not put the null in there. So let's create another array. Let's create an A3 down here. Let's make that 20 bytes. And let's say strcpy into A3, A2, and let's say we're going to limit ourselves to 4 bytes. So this is an uninitialized array. Who knows what's in it? After this, it's going to copy 4 bytes from A2 and it's going to put them in A3. Now, we'll look at the man page, but I happen to know that string copy says once I've hit 4, stop copying. And if I did not get a null because I reached the end of A2 before I got to 4, it will not null terminate that string. This is the kind of thing that causes all kinds of problems with a lot of programmers because they don't bother to read the manual. And this is the kind of thing that is why we end up with viruses. You'll notice that unterminated strings and overrunning the ends of arrays are like the #1 way to cause corruption in memory and self-modifying programs that basically are the hallmark of viruses. So let's look and see what happens here. Where's our beginning of our function? Here we go. C strings 3. There's our 6 with the nulls. There's our garbage in A2. Here's our A2 with the string copy. 1, 2, 3, 4, 5, 6 and a null, followed by random garbage. Here's the cat, or more accurately, the n cat. 1, 2, 3, 4, 5, 6, followed by 1, 2, 3 and a null. Okay. Now I said string n copy, and I said only take 3 or 4 or whatever it is from A2 into A3, so you can see these things. And because I hit my limit, which must have been set to 4, it stopped, and it did not put a null in here. Why? Because when we read the manual page for strncat, not strncat, it helps if you read the manual for the right command. Strncopy says that most n bytes of source will be copied. Warning! If there's no terminate byte in the first n bytes of source, then the string placed in dest will not be null terminated. Always read the doc. Okay. If we do copy enough, let's put it to 10. I don't think that there's more than 10 in there anyway. There was 6, 7, 8. Who cares? Let's go to let's call me crazy. Let's go to 15 here. All right. Now what'll happen is it'll copy the whole thing from, what did I do? Copy. I copied from A2 to A3. That's okay. That's why we ended up with what we got here, 1, 2, 3, 4, 5, 6, followed by the 1, 2, 3. And now look what happened. I said copy 15. What happened to all the garbage that was after this thing? I got, 1, 2, 3, 4, 5, 6, 1, 2, 3. And this is A3, and all these nulls are in here. Well, there's garbage down here after 15 that coincidentally happens to be zeros. But let's look again at the man page for strncpy. So if I said, like 15, if the length of source is less than n, which is the case right now, strncpy will write additional null bytes into dest to ensure that the total number of n bytes are always written no matter what. Aha! So let's modify our program a little bit. Let's set A3 equal to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V. I don't know what's 20. If you ever want to do this, by the way, I put my cursor here. I'm in VI. So if I type 20H, it just moved over to the left 20 characters. And that means I've got 2 characters too many. Now there's exactly 20 characters in this string. However, remember, that's still 1 too many. Let's go ahead and compile this, and I'll show you what happens if you try to initialize a 20-byte character array with a 21-byte value. All right, it should say, warning, this is too big. Initializer is too long, okay? Don't do that. Pay attention and count them out. Now, if I'm here and I type 20H, I go back and we have that 1 extra thingy right there to account for that null. So if I do this, now it's all happy. And what did I do that for? I did that so that I would put known value in there before we do this copy. Now look what happened. Remember, I did a remind myself. I got A3. I initialize it to all these letters followed by a null. So exactly all 20 of these will be initialized in here with a null in index number 19. I then said strncpy 15 bytes out of A2 into A3, and then I print it all out down here. So A2 at that time, okay, looks like this. A2 has this 1 through 6, 1, 2, 3, 4, 5, 6, 1, 2, 3 null. All right. And because I said copy 15, and it's a string copy, it copies these 9 printable characters. It found the null. It's not going to copy this junk down here. No. It stops copying when it hits that null right there. Okay? 1, 2, 3, 4, 5, 6, 1, 2, 3, null. And because I said 15, it writes all 15 bytes, 0 through 14. Any extra ones, nulls them all out. Notice down here, again, it doesn't know how big the array is. Even if I wanted it to, it would not know how to zero these additional ones out. Okay? So there's extra stuff hiding back here. Be careful of that. All right, so let's look for another thing here. Let's get rid of some of this extra noise. What does stir do? All right, what it is it's sometimes the documentation is written in terms of needle and haystack. Okay, so let's look at this thing. Char star p equals this thing. Strstr looks for a string inside of another string. Notice it returns a pointer to a character. There you go. There's your needle in a haystack. I saw that somewhere. Notice they're both const, so it doesn't modify anything in here at all. What it's going to do is it takes here's a big string, logically speaking, and this is a littler string, less than or equal to the size of the big one. Otherwise, it doesn't make sense to do this. So what it's going to do is it's going to say, I want to know if this string pointed to by this variable here, the needle, appears in the haystack. And if it does, return a pointer to the first occurrence of the first character of this string that appears in this variable over there. Okay, so let's see how this works. All right, now we got 1, 2, 3, 4, 5, 6 in there. Yeah, we'll do 2 passes on this. So if we say AY, and I say 45 like that. Again, these are strings, not numbers, okay? I just put digits in there so we can tell how big everything is. So if I say find the string 45 inside this AY array, it should find that 45. It should return the address of this thing right here. Okay? So when this thing comes back, let's have a little fun and say print this array. Now, I'm going to do this is not right, but I'm going to do it anyway. And we'll see why it's wrong in a minute. And then we're going to do this. Do we really care about this size of AY? Yeah, let's really screw this up to drive this point home. Remember, P is a pointer. What the heck does this mean? What is the relationship between this and this? The answer to that is almost nothing. The only thing that really is related is that if strstr finds this 45 substring inside this other string up here, P will point at it. So it's pointing up here in the middle of this string. If I were to print out this string starting where P is, it'll print out a 4, 5, 6 and stop, because what's a string? It's characters that are not null followed by a null. And if P points to this 4, it's going to print out this thing right here. If I use my print string array, as I coded it right here, it won't make any sense. If we print out a string array like this, what am I doing? This is so nonsensical. Both of these lines are just nuts right now. And again, I'm showing you this on purpose, because a lot of students mess this up when they're first learning. So, all right, so this is wrong. All right, this down here is wrong. Okay, let's run it. It will compile, it will run, and it will do something. Let's see what happens here, okay? Here's my 1, 2, 3, 4, 5, 6, and all the nulls. Why? Because we have a partially initialized array, and they pad it out with zeros. What's going on down here? I got my 4, 5, 6, just like I said was going to happen. Then there's some nulls down here. It only printed out 8 things. Size of P is 8, and strlen of P is 3. Okay, why is this the way it is? What the heck is going on here? What is P is the real question. P is a char star. It is not an array. It does not have a length that's determined by the number of elements in an array. By asking how big P is, I just asked how big a pointer is. Literally, what this is doing is it's asking what size of char star is. And pointers on a 64-bit operating system have 64 bits in them, which is 8 bytes. That's why size of P is 8, which has nothing whatsoever to do with the size of this thing up here. Okay? Now, because size of P is 8, we print out the 8 down here to know what it is. What is strlen of P? Strlen of P does make sense because P is a pointer to a character. It has a string in there that we have initialized, and as you know, it's pointing at this 4. So it should have printed the 4, 5, 6, right? Is that what we got? Strlen of 3, strlen of P rather is 3. I didn't print the string. Let's go ahead and print it out here so we know. You know, just by the fact that it's 3, should be a giant clue right there. If I do this, ENDL, let's put quotes around it so we know for sure. I very often will put quotes around things like I print like this because you never know. What if there's spaces after it? You know, you go through all this work and you get your output just perfect. What if P was pointed up in this string and there was a space after it? Let's go ahead and add a space just to make it fun here. So what's happening now? It'll print 4, 5, 6 and a space. If I did not put these quotes in here, you'd never know that you printed out P, which is 4, 5, 6 followed by that space right there. Okay, now we know the strlen would be 4, not 3, because I added another character in there. Keep your eye on the ball. It's like a card game. It would help me if I kept my eye on the ball and put a semicolon at the end of my code. Let's see what's going on here. Again, I skip a bunch of lines so I can find the beginning of my program. Okay, there is the same starting pattern we've always had, followed by the strstr to find where the 4 is. The 4-5 rather, I should say. It said find the 4-5 in this string up here, and it comes back, and P is pointing at the 4 up there. If we printed out the hex addresses, you'd see they all match. I'll leave that as a task for the viewer. You should do this sort of thing. There's my 456 and my space. That's why the strlen is 4. And when I printed out the value of P, look at that space in there. And if you did this and there happened to be a space, you just printed out that string, you'd never know there was a space hiding in there. That'll screw you up if the spaces matter. So that string ends here. Well, there's your null terminator. That's why the length of this string is 4. Just because you see 3 characters doesn't mean there's not a space hiding in there. Okay, so what's the takeaway in here? Be careful what you're doing the size of stuff on, all right? It's just a coincidental that was happened to be 8. And it's not too big and didn't run into some garbage, because if you accidentally printed out like 1,000 in here, this will probably die. The program will probably get a seg fault in here. Yeah. What did it do? Well, oddly enough, it didn't get a seg fault. It just kept going and printing what was there. Look at all the garbage in here. All right. Eventually, and if you heard the bell go off, one of these must be the bell character, right? That \B code, which I think is a decimal 6. Wow, look at all the garbage. Well, of course, it's 1,000, right? So it just kept on going. Eventually, if you make it big enough, it most definitely will have to fail. Let's put 100,000 in there. All right, eventually we'll run off the end of the stack, and there you go, and it got a seg fault. Wow, it went a long while before it died. Look at all this up here. There's just stuff in memory. Comp, sci, projects. Look at this. This looks like the path name to my program. Sitting right in the middle of memory out of nowhere. Games bin. You know what this is? Wow. This is the environment. Wow. That's subject of another class. That's CompSci 330. Take that class. It's in Unix and how all that fun stuff works from a higher level perspective of what your environment is when your program's running and how to use the operating system and stuff like that. All right, so that's what strstr does, and an example of how to use it wrong. Let's go ahead and make sure that we all understand exactly how it works. It didn't find a 4. It found the 4-5. So if I put 452 in there, what's it going to do now? It should return a null. Okay, if it doesn't find it, you look at the man page. Does strstr find the 452? There isn't one in there, as we know, because there's what are the 456? Is there a 452 in there? No. This is going to return null. Let's not print out. Let's not do that anymore. Let's try to print out 10. This is going to die right off right here. Okay, and the reason is because I'm going to try and print out the values starting at address 0, which is illegal to do. I copied too much code. Let's just comment out the wrong one for sake of example. All right. Yeah, I got that error because I just copied, including the definition of P, the pointer right there. Okay, so let's just get rid of one of them, the old one. And run this thing. And of course, I got a seg fault as soon as I tried to print it out. Again, there's the startup with the nulls after it. It said strlen is 7 because there's one of the 556 and the space is 7, followed by the null right there. This seg fault is because I tried to print out a string at address 0. So let's go ahead and copy that, comment that out, comment all these things out that will cause us to fail. All right. And we can see now, if we want to, we can print out the value that P points at, right? If you just try to print out P as a pointer to a character, cout will print a string. So if you cast it to avoid star, what you're doing now is telling cout that it's a pointer but you don't know what kind of thing it points to. So now it has no choice. It will simply print out the value of the address itself. Again, this is sort of like that 8-bit characters, confusing it to try and print the character glyph instead of the numeric value that represents the character, right? This doesn't change the value of this variable in any way. Neither did casting it to an int and a character before. It still had the same value, but the type as perceived by this the insertion operator is now different. So when you run this, it cannot help you by interpreting what the value means. So it prints out a 0 because the value of a pointer to null is 0. The null address is a 0, just like the null character is a 0. And by that I mean that's this thing, null ptr. We talked about that in the pointers videos, all right? So there's a whole bunch of these. I don't need to go over every single one of them. You know, go ahead and do man string, and like I did, and read about all these things. Case-insensitive comparisons, index, find a character, compare things, all right? There's whole parsing routines, tokenizers, tons of stuff. The point is, these things are utility functions that you can find useful if you need to process data when you're given a C-style string. Well, that should give you a toehold on the entire subject. You can read the doc to find out the rest. Thanks for watching. See you next time.